Thank you very much. Thank you for inviting me here, for the organization CNIT and AFCEA, and to all the people who provide the facilities for it. I'm working in Vitrociset. In the Cyber Intelligence Competence Center. I followed the project almost since the beginning, so I participate actively into the design and implementation. We are going to, in this 10 minutes, we are going to talk about generally the experience. I'd like to give you an idea, a very high level, what we have done, how we have done it, how we achieved the implementation of the demonstrator. And we are going to talk about this topic. We have already seen this map illustration, and I'd like to just highlight the value that at least for us as a Vitrociset or whatever we believe in. Centralizing the security, as we have done in the demonstrator and the Scout project, it gives us opportunity and flexibility also to do some economic scale. For example, one of the two scenarios that we can see here, and the green light, according to, for example, a fault in one ground station that make it possible, for example, to analyze data coming from the satellite, could be actually redirected and use the processing power from and the system of another ground station, because we have the SDN core, the rerouting possibilities, and this could be done by having a Scout central engine that take according to the policy and under the supervision, of course, the expert intervention and do so. Another scenario is the malware. For example, study. At one point we detect some malware, we can reroute and not stopping the activity, detecting activity, but using the honeynet, we can reroute the traffic and make it possible that the attacker still try to do what he's doing, and so we have the ability to study its own behavior, techniques, and methods, and so on. What at the beginning, what we find, we have this is the general idea. What we found, we have a very huge system, lots of components. We have the physical part combined by 6 sensors, 5 different technology, and 4 different partners in 4 different countries managing this subsystem. We have a data fusion, target classification, MCU, risk assessment, cyber sense recover, and the test bed where we have to validate the project. All these subcomponents are managed by different partners, so the complex to integrate all of these components is quite challenging, and we have some several constraints that probably are familiar for all of us in terms of limited budget and time, and the logistics. So our approach was to first having the site survey in Azimatera. We saw exactly what we have to do. We took all the information needed, and we fixed remote validation actually would be, and I'll show you later on, we opted to work with a lab environment, a distributed lab environment, to make possible that all partners were able to develop its own component, and then a specific point in time, two of them, validate the communication in order to improve, etc., and test. We have the validation in Matera last year in September, October, and we have a further validation at the beginning of this year for further analysis. This is the general structure, the distributed lab environment that Vitrociset set it up with the help also the AFCEA, and of course the test bed was located in AFCEA and stayed there. We have connected the virtual lab facilities in Vitrociset here in Rome with VPN, site-to-site encrypted communication, and we provide to the different partners a VPN connection in order to be able on demand to access to the lab and communicate with all the sub-components that were deployed in the virtual lab in Vitrociset, and they were able to develop their own. Now, this is the where we've done the validation, and the main threats that the Scout project, the demonstrator, had to face, we wanted to include in our demonstration, in our use case, was related to the internal physical violation, an external one, an internal physical intrusion, the cyber incident, with different for cyber DOS attack mitigation, the malware detection, business continuity, and malware behavior study. This is not only cyber attack related, the management of the cyber part, but also we are talking about business continuity, so any kind of security incident, cyber security incident. The demonstrator, the capabilities, some key points that we develop in the demonstrator are related to the possibility to have monitoring on the cyber and physical part in separate way or in integrated way. The demonstrator actually is the correlation to the threats and the possibility to have the risk-based policy management, so the ability to fix a policy with the expert of the critical infrastructure, in this case the AFCEA ground station. The demonstration is able to propose according to the threats and the event occurred, some remediation solution, so it can propose different solutions according to its knowledge and according to the risk. It's able to apply this countermeasure automatically or just propose the countermeasure to the operator in order to obtain a validation, the countermeasure, and give the ability to the operator to apply by its own this countermeasure. This is a little overview of the sensor, how they were deployed. On the background, you see a portion of the AFCEA ground station material. You can see on the yellow area, the warning area. It was the area actually under the focus of all physical sensor. And there is on the bottom line in the circle, purple one, the alert area, which was the antenna, which was signed as a critical area to be monitored. And on the top, still on the circle, is another alert area with the ground segment equipment. Is a part of the internal indoor coverage where all the events happen. These are the physical scenario were simulated by using cars and people moving around the facility, so the sensor were able to record the passage. This is how it looks like the logical systems. As you can see, there are a lot of virtual machines, there are a lot of hardware. There are more than 20 virtual machines implementing the different parts, the different components. And what I want to highlight is the fact that the approach we use to make possible to use entirely the virtual the distributed virtual lab we had here in Vitrociset. We moved in Matera, and it was just another reconfiguration. The Scout system is very modular, and the implementation, the techniques and the methods we use to implement this demonstrator, which is not a product but is a demonstrator. We had in 1 week, in less than 1 week, we are up and running with deploying all the sensor and deploying all the machine moving from Roma to Matera. And the software-defined finite networking was one of the innovative parts. It's at the core of the flexibility of the Scout system. On the left, you see a point of view from the application there for the recover part, which see the network in its own way and is able to communicate with every part. Another very valuable part of the project was the real-time communication subsystem, the DDS, data distribution service, which actually make possible to guarantee the real-time paradigm in all the communication, implementing the publish and subscriber model. And here I'm finishing now. I just want to show you the real part of what we have done, how it is, because it's still up and running. There you can see on the left the 4 SDN switches, on the bottom is the main server. And here there are other workstations used and virtualized for the probes and the honeynet and the ground segment simulator. And these are the CMAP emulator used in the demonstrator. These are the 3 sensors on the top of the building that are actually illuminating the street you see before. And just to conclude, you can see here on the big screen the graphical user interface. We have at that moment in Matera validated, illustrating all the part, it uses dynamic data and it show real-time events as they happen in the moment. I conclude here very briefly my intervention. I'm really open for any question you may have.